So we are going to learn geometric sequences and how geometric sequences are different from arithmetic sequences. So first of all, we say arithmetic sequence, and we quickly do a recap of what arithmetic sequence is. So arithmetic sequence has something called a common difference. Common difference is D. If I put a term, if I write a sequence as a 2, 4, 6, 8, and so on. So if you see, the difference between two consecutive terms is positive 2 across. So this difference, which is constant throughout the sequence, in other words, if this difference is added to the previous term, you get to the next term. This type of sequence is called arithmetic sequence. So what you're doing eventually is, in order to go to an, or probably not an, it's a tn. Tn, what you're doing is, you're doing a tn minus 1 plus d. This is how you do it. A lot of books also refer it like this: tn plus 1 equals to tn plus d. So in both the cases, both the formulas, tn and tn plus 1 or tn minus 1, they are consecutive terms. So if you add the common difference to the previous term, you get to the next term. And the formula, if you want to go to the nth term, directly using the first term, which we refer as a, is this. So if you want to go to term 40, my n is 40. So if I know the first term, so for example, my first term here was 2, and I want to go to the 40th term. So I say 40 minus 1 times 2. So eventually what you get is 2 plus 39 times 2. 39 times 2 is 78 plus 2. So the answer is 80. So you directly go to the 40th term using the nth term formula. So these three, if I just mark it in different colors, so this and these two are two prime formulas that can help you generate an arithmetic sequence. Now, graph of an arithmetic sequence, if your d is greater than 0, the graph of arithmetic sequence is a positive slope, where on the x-axis you write your term numbers, your n, and on the y-axis you plot the value. And if your d is less than 0, you get a negative slope straight line. You get a straight line, you get a linear curve, because it is an addition, and that remains constant. Here you've got n, and you've got tn. This is, in a very nutshell, what an arithmetic sequence is. Let's understand now what is geometric sequence. Now, geometric sequence, number one, is a sequence. I'll give you an example. Let's write a sequence. Now, let's quickly analyze what's happening in this sequence. This, from 2 to 4, you're actually multiplying 2. The previous term, so you're multiplying the previous term with this number, multiplying, not adding or subtracting. Then you again do that with 4, you multiply 2. Then you again do it by 2, you multiply 2, you get to 16. And if I ask you what is the next term, so it's easy, you'll say, okay, multiply 2, and you get to the next term, 32. So here, The basic difference between arithmetic and geometric sequence is the operation of the operation that we are using to get to the next term. Here we are using multiply. So we are multiplying the previous term with a number. So we multiply the previous term to get to the next term. And this number that we are multiplying is called common ratio. It was common difference in the world of arithmetic sequence, but this is common ratio R. Why it is called a ratio? The ratio word comes from the very basic formula of how do you derive this R, how do you calculate this R. In the world of arithmetic sequence, if I write it AS, how did you get your common difference, your D? What you used to do was, you were doing Tn plus 1 minus Tn. So you were subtracting the two terms and you were getting the difference. So in here, if you see, what we are getting is we are subtracting. So I subtracted 4 from 2 and I got this 2. But in the world of geometric sequences, 2, 4, 8, 16, what I'm doing is I'll pick up one of the terms, let's say 4, and I divide it with its previous term. Divide it. And this fraction is nothing but ratio, right? Ratio is something over something. So this ratio is basically 4:2. And if I simplify this ratio, I get 2 over 1, which is actually 2. So this jump is multiplied by 2. Similarly, if you pick up any two consecutive terms, this ratio should be same. So I'll say 16 over 8. You divide it, you get 2 again. So this remains constant throughout your sequence. And hence it is called common ratio R. Is that clear? Yeah? Yeah? Cool. Now, what is the formula for geometric sequence? The basic formula of geometric sequence is that A of n plus 1 is A of n times R. So let's apply here. Let's apply here. My sequence was 2, 4, 8, 16. My R, you just calculated, R is 2. So this was T1, T2, T3, T4. If I want to go to T5, so my n is 5. Let's plug n here and I'll say, okay, I can use Tn or An, they're one and the same thing, right? Rather, I'll correct this and I'll write it like T of n plus 1 equals to T of n times R. One and the same thing, it's just the usage of what variable you're using to represent your sequence. Now, I want to get to T5. So I'll say T5 equals to, and I'll use this formula, T of n. So I need a T4 times R. Let's plug that in. What is T4? 16. What is R? 2. So it is 32. So T5 is 32. So this formula helps you to jump on to the next term from the previous term. Now, this R, now let's take another example. Let's take another sequence. That is a reverse sequence. 16. Or probably we'll start with 32, 16, 8, 4, and I want you to know next. I want to know the next one. Let's find what R is. R is always the next term divided by previous term. So if I pick up any two consecutive terms, the next term divided by previous term. So this is basically 1 over 2, half. So you see your r is actually a fraction, so which is between 0 and 1. It is 0.5. So when your r is a fraction sitting between 0 and 1, you get a decreasing trend or decreasing geometric sequence. It is as good as when your d was a negative term in arithmetic sequences, you used to get a decreasing sequence. So for example, you had 16, 14, 12, 10. And I'll say what is next. So what you're doing, minus 2, minus 2, minus 2. So here your d was a negative number. Here the r is a fraction between 0 and 1. So when you get a fraction between 0 and 1, you get a decreasing geometric sequence. And in the world of arithmetic sequence, when you get a negative d, not a fractional d, when you get a negative d, it behaves exactly like a decreasing sequence in the world of geometrics, in the world of your geometric progression. So that's the basic difference. Now, how does the graph look like? How does the graph look like for a geometric sequence? So if your d, if your r, common ratio, is greater than 1, that means any number more than 1, the graph will look like this, a parabolic graph going upwards. It is not a linear graph. So that's the basic difference between geometric sequence and arithmetic sequence. Here you will plot the n and here you will plot Tn. And if your r is between 0 and 1, you get a graph like this, a curve coming down with a negative slope. Whereas your arithmetic sequence with your d greater than 0, I should say, or a positive value, this is how it's going to be. And if your d is less than 0, this is how it's going to be. So this is the graphical difference between arithmetic sequence and geometric sequence. Now lastly, if I want to go to the nth term straight away, without going through each and every term. So in the world of arithmetic sequence, the formula was your t of n equals to a plus n minus 1d. Now, if you know the first term and you know the common difference and you know where you want to go, you can directly use this formula to go to the nth term. In the world of geometric sequences, you've got a very similar formula. You've got t of n equals to a, which is the first time, r raised to the power of n minus 1. So that is the prime difference between the two sequences from an nth term perspective. So if I say there is a sequence, geometric sequence 2, 4, 8. This is T1, T2, T3, and I want to go to T5. So my n is 5, and I'll say a is 2, 2 times r is 2, raised to the power n minus 1, which is 4. So that will be 32 straight away. That is the nth term formula for geometric sequences. So here I have now basically covered in a very nutshell what is the difference between geometric sequences and arithmetic sequences. Right? I hope that makes sense.